All right, let's take a look at this thing, right? So this is the maximum velocity, right? So the maximum velocity, it's just we can read that right off the graph here. Looks to be about 30, let's see, 32, 34, 36, 38, 40. Yeah, it's 32 meters per second. Okay, and our period is, we start it there. Don't we finish the period right here? At 8 seconds. Okay, and then x naught, this takes a little figuring here, so we gotta, okay, so we know that v, maximum velocity and the maximum position, or the amplitude, right, are related this way. Okay, we know that oh, and then we got to figure out omega. So omega is 2 pi over t, so that's 2 pi over 8, because our period is 8, right? So that's going to be pi over 4. Okay, so v, if we just sort of recast this, right, v is, let's do this, v is 32, the maximum velocity is 32 from there, right, is equal to pi over 4 times x naught. Doesn't that mean that x naught is, well, 4 times 32 is 128 over pi, right? So this guy is 128 over pi. That's our meters, I guess, right? If we wanted to label the units. All right, so let's see. We've got the right x naught. So an equation for the velocity. Well, doesn't that look like negative cos? Yeah, so let's go with that. So our v is negative 32 meters per second cos, and then our omega is pi over 4. So pi over 4t, right? And then these equations are coming from the data packet like this, right? Only see this, there's no equation for negative cos. I'm just throwing the negative in there because this looks like a negative cosine, right? Okay, but notice that it's negative omega x naught, right, or whatever that maximum velocity, cos omega t, right? Okay, now our x, if this guy, we know that if v is positive cos, that x is positive sine. So if v is negative cos, x will be negative sine. Okay, so let's figure that out. An equation for its, oh, this is not velocity, this is position, for position. Okay, so that's going to be negative, x is going to be negative something sine omega t, right? All right. Okay, so let's take a look at this guy. It's going to be this guy, right? That goes in there. The maximum, the amplitude, right, is 128 over pi. Okay, so now we've got the right formulas here, right? And now we got to throw them into this graph, right? Well, this graph is hard to read. Okay, like for 2 seconds. Okay, remember this is a graph of velocity, so I know that my velocity, this middle thing, at 2 seconds, it's 0. Okay. Well, now if you recall, for the position. For the position, if you look at this position graph, when the velocity is 0, the position is either at a maximum or a minimum. So the question is, which one of these is this, right? So let's look at the velocity here, right? The velocity is then suddenly going to become positive, isn't it? Well, when is the velocity ever 0 and then it becomes positive, right? When does that happen? Well, let's think about this, right? We got our, let's draw a picture. Here's equilibrium, right? Here's positive x naught. Here's negative x naught. Okay. When does it ever get 0 and then become positive? Well, if we're over here and it becomes 0, after that it becomes negative. It goes back toward the origin. Okay. But if we're at the minimum here, okay, after it gets to 0, it becomes positive again, right? So this, I believe our position will be a negative maximum, okay, which of course makes our acceleration. Acceleration, by the way, is easy, okay? Acceleration is the slope of this graph, because remember, this is a velocity graph. It's different, right? So the slope of this guy is positive. So I believe our position will be negative, our velocity will be 0, and our acceleration will be positive. So let's see if that's true. Okay, let's figure this out. So our velocity is going to be, let's figure that out, minus 32 cos pi over 4 times 2. We can do this. People who paid attention in math class will realize that we're headed towards 0 here, but let's just go for it. Minus 32 times cos pi divided by 4 times 2. It's 0. Okay, so let's figure out our x. Okay, our x should be, by the way, negative 128 over pi. But let's, suspense. Okay, so x is negative 128 over pi sine of pi over 4 times 2. Right, we're just plugging 2 into this thing, right? By the way, you have to be in radians. If you're not in radians, you're not getting any of these answers. Okay, so the opposite of 128 divided by pi times sine of, pi divided by 4 times 2. Boy, I hope that works. Ooh, I get negative 40.7. All right, so we did get a negative number. The question is it the actual maximum thing? So let's just go 128 divided by pi, which is going to be, that's what the answer is, right? So indeed, yeah, we did get the negative maximum. We figured it out, right? All right, and then our acceleration is going to be the opposite of omega squared times x, right? So that's the opposite of pi over 4 squared, right, times negative 40.7. Okay, so I'm going to take the number on my calculator, the negative 40.7, and multiply by the opposite of pi divided by 4 squared, and I get 25.1 meters per second, and I get a positive number, which is indeed what I should get, and that's meters per second squared. Yeah. All right, so now let's look at 5 seconds. Now let's see, 5 seconds, that's about here. Okay, my velocity is definitely positive, right? Okay, notice that my slope of this, remember the slope of velocity is acceleration, right? The slope of this is negative, so therefore acceleration is negative, okay? So my acceleration is going to be negative, which of course means that my position has to be positive, okay? I'm somewhere here, right? And I'm being pulled back toward the origin, okay? No, wait, yes. I'm to the left. No, I'm to the right of it, and it's pulling me to the left, okay? So those are my predictions, right? So we'll have a positive position, positive velocity, negative acceleration. So let's go ahead and figure out our velocity. Velocity should be, by the way, something like, I don't know, between 20 and 25, it looks like, closer to 25. Let's figure it out. V is minus 32 cos pi over 4 times 5. All right, what is that? Opposite of 32, remember you got to be in radians. Cos pi divided by 4 times 5. 22.627, so 22.6 meters per second. All right, let's see, x is going to equal the opposite of 128 over pi. There's a parenthesis for you. Sine of pi over 4 times 5. All right, we can do this. Opposite of 128 divided by pi times sine of pi divided by 4 times 5. What did I predict? I predicted that this would be a positive x. I hope it is positive. Oh, it is. Positive 28.8. That's meters. All right, and then our acceleration is the opposite of omega squared x. And we just figured out x, right? X is this. So we're going to go the opposite of pi over 4 squared times positive 28.8. Okay, so I'm taking the number on my calculator. I'm going times the opposite of parentheses pi divided by 2, and then square that quantity. And I get negative 71. Meters per second squared. All right, is that, do we get that right? I think so. Let's just double check. Oh, no. I did pi over, yeah, it's like, that seems like a big number. Okay, hold on. I did pi, let's go this guy, times the opposite of pi over 4. I did pi over 2. Negative 17.8, okay. Meters per second squared. I just got a number 4 times too big, which is really pretty close in physics land. All right, so yeah, so interpreting, by the way, figuring out the positives and negatives for this that's tough. Okay, and that's what the next couple problems will be. Okay.